let's go on to the next one. So let's convert the point 3, 2 into polar coordinates. So we're given the Cartesian point 3, 2 and convert it into polar coordinates. So first let's draw the point. So we have that point there. That's going to be 3, 2. It gives you just at least a little bit of an idea of what we're expecting. We're going to be expecting sort of a shallow angle like that, and the distance, do quickly in our head by the Pythagorean theorem, is going to be the square root of 13. So let's just put up the formula. So what we know is that r is equal to the square root of x squared plus y squared, and theta is going to equal arctan of y over x if x is greater than 0, arctan of y over x plus pi if x is less than 0, pi over 2 if x equals 0 and y is greater than 0, and negative pi over 2 if x equals 0 and y is less than 0. So we can see that we can clearly see which of these rules apply. What we have is we have x is positive, which means that we're simply going to be applying that rule, and that means that we can write that r is going to equal the square root of 3 squared plus 2 squared. That equals the square root of 9 plus 4, or like I had said earlier, the square root of 13. Did that really quickly in my head, but I just wanted to show you how we got there. And theta is going to equal, using that first rule, is going to equal arctangent of y over x, which is 2/3. Now this is not a ratio for which we know arctangent. Basically, we know that arctangent of 0 is 0, arctangent of 1 over root 3 is 30 degrees or pi over 6, arctangent of 1 is 45 degrees or pi over 4, and arctangent of root 3 is 60 degrees or pi over 3. We don't know anything about the arctangent of 2/3, so that's simply how we have to express this. So the answer is going to be square root of 13, that's the r, and arctangent of 2/3, that's the theta. And just to be clear, this should be reviewed from Calculus 1, but the inverse trig functions, they do give you angles. So arctangent of some ratio should be correctly understood as an angle. So this does meet the format that we're looking for. So let's look at this problem. Let's convert negative 4, 4 root 3 into polar coordinates. Just to remind you, I won't write it again, but here was the formula for converting Cartesian coordinates into Cartesian or rectangular coordinates. They mean the same thing. Converting Cartesian coordinates into polar coordinates. So let's just use that. Let's write r is going to equal the square root of negative 4 squared plus 4 root 3 squared. So that equals the square root of 16 plus, this is, if I square this, I'm going to get 4 times 4 is 16, root 3 times root 3 is 3, so that's going to be 16 times 3, or 48. That gives us the square root of 64, which equals 8. So the radius is 8. Now let's do the theta part. Here we have x is less than 0, so I have to apply the second rule. That's going to be the one here, where I find arctan of y over x, but then I add pi to it. So that is going to give me arctangent of 4 root 3 over negative 4. And then once I find that, I'm going to add plus pi. So this is going to be, by a little bit of division, that's going to be arctangent of negative root 3. We know that root 3 is one of those values for which we do know the arctangent, and since arctan is an odd function, arctan of negative root 3 is just going to be the same as negative arctangent of root 3. So that's going to equal, I have to add pi to that, and this is going to equal negative pi over 3 plus pi, which equals 2 pi over 3. Oh, there we go. Okay, so the answer is 8 comma 2 pi over 3. And by the way, let's just graph this just to verify that this makes sense. So What we're looking for is an angle of 2 pi over 3, which is roughly along that direction. And we're looking for a point that's 8 units away from the center. So that gives us this point here. That makes a lot of sense given what point we were given. I know I haven't put any scale in, but just to give you some idea, this is, oops, sorry, this is approximately 6.8. So it certainly makes sense that if I call that 4 units, then this is going to be 4 units, and it would certainly look about right to call this 6.8 units. So it certainly looks like the point is in the right place based on where it had originally been described. Note what would have happened if I had not added this pi to the arctangent function. I would have gotten a point. I would have gotten a point down here instead. So it would have been necessary that the angle that gives us the angle of negative pi over 3 is going to be down there. So that's why it was necessary to add pi in order to get to the right place. So anyway, that's how this conversion works.